Hello, welcome to Zigmatech Learning Hub. I will be your instructor for chemistry. For this class, we are going to be taking our exercises from the ExamGuide app. If you don't have the application already installed on your device or on your phone, I will want you to download the app in order to follow along in this class. ExamGuide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, JCE, KCPE, IJMB, JUPEB, Calbepedia, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. Welcome again once again to this class or to this lesson. We're going to talk about the particles of matter, part 3. Okay, we've talked about the particles of matter, atoms. We've talked about the ions. And the last particle of matter we're going to talk about is the molecules. Okay, now, at the end of this lesson, you will know about the molecules, differences between molecules and atoms, and differences between molecules and ions. Remember, these are the 3 particles of an atom. Now, molecules, when they say molecules, okay, molecules was, a molecule was first of all talked about during the creation. Okay, when the world was created, we know that molecules started at that time. Because in 430 BC, Leucippus and Democritus argued that the universe was made of atoms and void in the discovery of molecules. Now, inside these atoms, we got the molecules inside the atoms. Okay, and the void means shapeless. The void means shapeless. In essence, it's telling us that the atoms that provided the molecules were shapeless. Not until the shape of molecules came to play. Okay. Now, these molecules, even the great mathematician, uncle was Pythagoras, still brought out his ideas using line and symbols and the measuration circle of a woman in knowing what molecules are. Why? Because the blood is a fluid. Remember, I told you about the liquid, a free-flowing substance. In essence, blood is a fluid, and in that fluid, every fluid has content of molecules. So for him to understand how molecules was, he started using the measured circle of a woman, 12 to 12, in this calculation of bringing out molecules. That particular mathematics is called mensuration. I know those mathematicians, they are there. So it was used in calculating these molecules. But we still do not have an idea about molecules until James Perrin came in 1926. A French scientist, James Perrin, came in 1926 and discovered the molecules. He discovered the molecules and told us that these molecules are the combination of atoms. Okay, the molecules are the neutral part of the atoms. The combination of the neutral part of the atoms, he said that is what forms a molecule. Remember, John Dalton said these atoms are indestructible. In essence, they come together to form things. 2 atoms will come together to form things. And he came to realize, if 2 atoms come together, what are they forming? What are they forming? If I bring egusi and meat, fish, everything, join them together, they're going to form a goosey soup. Now, these atoms, what are they forming? That is why James Perrin came and called it molecules. 1926, James Perrin discovered the molecules. Now, what is a molecule? A molecule is the smallest portion of a substance that exists independently and possesses the chemical and physical properties of the substance, be it an element or a compound. Now, there's a confusion here now. Not really a confusion, okay? Most people do not know these things. As you can see on the screen, the molecules are hitting themselves. Okay, that's how molecules behave. They come, they hit themselves, and so on and so forth. I told you that during the ions, that the positive charge, the charges in an ion is called, the charges in an atom is called the ion. Now, that one that has no charge, what is it called? That is the molecule. The charged part of an atom is the molecule. Take note. Now, they say the molecule is the smallest portion of a substance. In essence, every single substance has a molecule. Every single substance has a molecule that exists independently and possesses the chemical properties, the chemical and physical properties of the substance. In essence, the molecule will take part in that reaction, unlike the atom. The molecule will take part in the reaction and will remain unchanged after the reaction, unlike the atom. For the atoms, bonds are broken. The atoms are broken. Okay? The atoms are being broken to form this molecule at the end of the reaction. But this molecule is the smallest portion of any substance at all. Any substance, the smallest portion, any substance, that it will take part in that chemical reaction. Because for it to possess the properties of that substance, it must have to take part in the reaction of that substance. It must have to take part in everything that substance is going through. And it is going to possess the chemical and physical properties of that substance, be it an element or a compound. It is either an element or it becomes a compound. Now, chemical properties and physical properties. In essence, the molecule will still be the smallest portion of a compound and still be the smallest portion of a mixture. Why? Because they said it's going to possess the chemical and physical properties. Remember, chemical properties are properties that are associated with chemical changes, and physical associated with physical changes. So in essence, these properties must have to come to play when a molecule is taking part in the reaction, be it an element or a compound. Now, that substance is telling us that it might be a chemical substance or a physical substance. So not all compounds, not all substances are compounds, but every compound is a substance. Not all substances are elements, but every element is a compound, is a substance, sorry. Now, for it to remain the same after the reaction, they said it exists independently. For it to remain after the reaction, that means it's taking part, but it's not being consumed inside the reaction. It's not consumed. It's like the egusi, it's like the salt. You put a salt in a food. Okay? Let's say you put a molecule of salt in a food. As you put the molecule of salt in the food is going through a reaction called boiling. Now, the whole of that soup, of that food, will taste the salt. The salt will not taste the meat. It is the meat that will taste the salt. In essence, that salt becomes a molecule in that particular thing. Because the smallest thing you put in a food is salt. That's the smallest thing. And it exists independently. Why? Because it takes part during the reaction, but it's not consumed. In essence, it takes in the whole properties of that food inside the pot. Everything you taste will taste salt. That is, and that portion that a substance will take part in a reaction and remains the same, exists independently after the reaction, is called a catalyst. In essence, a molecule is a catalyst. Why? Because a catalyst is any substance that speeds up or alters a reaction and remains unchanged afterwards. After the reaction is remaining unchanged. After the reaction, it still exists on its own. After the reaction, is just like that. It's like a molecule of hydrogen reacting with oxygen to give you water. In the formula, in the molecular formula, you're seeing the hydrogen as 2. You're seeing the oxygen as 1. In essence, the molecule remains the same. It's not being consumed. And they say this substance there is made up of a substance. That substance there you see is either a compound or an element. Because there's the smallest portion of a substance that exists independently and possesses chemical properties of the substance, be it an element or a compound. In essence, this substance is an element or a compound. So if I tell you that the molecule is the smallest portion of an element, you won't tell me I'm wrong. Just like the atom. We say the atom is the smallest particle of an element. and I still say a molecule is the smallest particle of an element, you will say I'm wrong. If I still say a molecule is the smallest particle of a compound, you will say I'm wrong, because elements come together to make up compound. And these atoms in the element are what breaks, that is what breaks to form these molecules. In essence, the combination of atoms brings out a molecule. The combination of atoms brings out what? A molecule. And we know that an atom is electrically neutral. So in essence, the molecule is an electrically group of atoms. Take note. If you don't know how to define this big grammar, you just tell them a molecule is an electrically neutral group of atoms. A molecule is an electrically neutral group of atoms. Why? Because in the element, there's an atom. In the compound, there's an atom. The atom changed. Okay? The atom changed when it formed the compound to be called a molecule. In essence, the properties of an atom will still be the properties of an element, of a molecule. Why? Because the atoms only changed to form a molecule. It's like, let's take for example, we are 4 in the house, okay? And we exist independently. My name is Moses Onwatuegu. My sister's name is Sarah Onwatuegu, for example. My brother's name is John Onwatuegu. We exist independently, Onwatuegu, separately. Now, when we come together to form one family, our name will still be Onwatuegu. In essence, we scattered independently, we are atoms. Now we came together to form a molecule, and we are still called Onwatuegu. So in that context, Onwatuegu's blood still runs in our vein, whether we are independently or we came together. So in that context, these atoms that are electrically neutral, that are found in the element, okay, in the compound, they came together to form the compound via the elements. Now, their name only changed from atoms to molecules. Their properties still remain the same as electrically neutral. So, the smallest portion that exists independently, okay, is in any substance that takes part in the chemical reaction, be it an element or a compound, is a molecule. So, and I told you anything that takes part in a reaction and remains the same after the reaction is called a catalyst. So you can say a molecule is a catalyst, or you can say a molecule is a chemical catalyst, or you can say a molecule is the combination of the neutral atom. Okay, a molecule is the combination of the neutral atom, or it is the neutral atom. You're correct. So, take note. A molecule is the smallest particle of an element, or the smallest particle of a compound. Now, I give an example. Hydrogen molecule, A subscript 2, nitrogen molecule, the ozone, okay, it has 3 molecules, the calcium oxide, the glucose, okay, water, and so on. Now, these things you see, okay, has 6 atoms of carbon. It has 6 atoms in the molecule. I've told you what all these things are, okay, the subscripts and so on and so forth. Now, the next one is classes of molecule. Molecules can be classified into 2, homonuclear and heteronuclear. Homonuclear consists of atoms of one chemical element, while heteronuclear consists of chemical compounds composed of more than one element. So now these things you see, this identification of subscripts tells us the number of atoms in the molecule. I told you every element is a molecule, but not all molecules are elements. I told you that. So in essence, the homonuclear means homo, means one. So only one element. While hetero means many. That means to say elements came together to form this particular compound. Now if you check the oxygen has 2 atoms in the molecule. So it is called oxygen molecule, nitrogen molecule, phosphorus molecule. Okay, now the water molecule, tetraoxide sulfate 6. If you check the molecules in hydrogen, there is 2. Molecules in sulfur, there is 1. Molecule in oxygen, there is 4. So these are the classes of molecules, depending on the substance. Okay, the first one talks about elements. The second one talks about compounds. So when you see a class of molecule, when you see an element, you know that the class of molecule it belongs to is homonuclear. When you see a compound, you know the class of molecule it belongs to is heteronuclear. Now they say types of molecule. If you look at the types of molecule, we have monoatomic, diatomic, and polyatomic. I told you molecules are neutral group, electrically neutral group of atoms. Now if you check the names, the types of molecules, they are being called according to the characteristics of an atom. They said monoatomic, meaning one atom. Diatomic means 2 atoms. Polyatomic means many atoms. Now, if an element has 1 atom, it is called a monoatomic molecule. Why? Because it is the atoms I told you that come together to form these molecules. And I told you that the main particle of matter is the atom. So from the atom, we know the kind of molecule that the element possesses. Now, example of monatomic, you say the helium, argon, krypton, xenon. These things are just molecules. If you see an element written alone, we know that it is monatomic. If you see an element that has a number of atoms in it, we know that it's diatomic. If you see an element that has more than 2, we know that it's polyatomic. Now, the diatomic are molecules that have 2 atoms. The hydrogen, yes, the chlorine, the oxygen, the magnesium, and so on and so forth. While the polyatomic are molecules that contain more than 2. The ozone, sulfur has 8, phosphorus has 4, carbon dioxide has 3, because the carbon is 1 and the oxygen is 2. Water has 3, the hydrogen is 2 and the oxygen is 1. Benzene has 12, the carbon is 6, hydrogen is 6. So if you check these particular compounds, now remember the monatomic are just elements with 1 atom, like the helium. Most of these monatomics are the noble gases. They have 1 atomic structure. While the diatomic, hydrogen, chlorine, oxygen, okay, the diatomic are mostly electronegatives. What do I mean? They are mostly non-metals. Mostly non-metals. You know, magnesium too is a diatomic, but most of these diatomic molecules are mostly non-metals. While the polyatomic are mostly hydrocarbons and gases. So take note. Now, if you see a compound, okay, you know that it is a polyatomic. A type of molecule called polyatomic. And a class of molecule called heteronuclear. If you see a diatomic, it is called, a diatomic is a type of molecule called, if you see hydrogen molecule, maybe you see any element that the subscript is 2. That the subscript is 2 is a diatomic molecule. And you know that this is homonuclear. So take note. Now, structure of molecule. Molecular structure is also known as molecular geometry. Geometry, we know that geometry talks about structures. Okay? Is the 3-dimensional structure or arrangement of atoms in a molecule. How these atoms are being arranged in a molecule is the structure of the molecules. Remember, I told you that the molecule cannot exist without the atoms. It is the atoms that come together to form the molecule. And I said, note, understanding the molecular structure of a compound will help you determine the polarity, 1, reactivity, 2, phase of matter, magnetism, color, and the biological activity. How does this particular thing react? Okay? How does the compound, I said understanding the molecular structure of a compound will help you determine how does this compound react with other elements or with other compounds. What phase of matter it is. What kind of matter it is. Remember, it is the molecules that make you know the state of matter. Where the molecules are faster, we know that it is a gaseous state. Where the molecules are fast, we know it's a liquid. Where the molecules are slow in movement, we know it is a solid. Magnetism. How do they attract? Remember, there will be no reactivity without magnetism. And there will be no magnetism without bonds. The attraction brings the reactivity. Okay? How does the molecules move to attract? How does this bond break to form the compound? Now, it is a molecule that determines the color of the compound. What do I mean? Hydrogen is colorless, oxygen is colorless. They brought out their molecules, bonded together, and gave us water that is colorless. And the biological activity, that is the characteristics. Okay? How do they operate? How do two gases come together to form a liquid? Now, if you understand the structure of the molecule, you will know how they came together to form a liquid, having their change of state. Okay? The molecules and the atoms themselves change. It is not the element that does the changes. It is the molecules that hit together to form this particular compounds. Now, what is polarity? Polarity. What is polarity? Polarity is the distribution of electric charge over atoms joined by a bond. When we get to chemical combination, you will know these atoms and molecules, how they join together to form a compound. Okay? It's a distribution of electric charges. Take, for example, sodium and chlorine are two different charges. Sodium is positive and chlorine is negative. Now, they will bring out their charges, first of all. When the electric charges come, they will bond together over the atoms. When they bond together, they'll give us a compound that is sodium chloride. Now, in that sodium chloride, the molecules, the smallest part of that sodium chloride is the molecule. The distribution of electric charge over the atoms joined together by a bond. Now, these atoms in that sodium chloride forms a molecule. So, when they distribute their charges, okay, their atoms go with them. The sodium has more positive than negative. The chlorine has more negative than positive. I told you why an anion is called an anion. Okay, I told you why a cation is called a cation. Cation is called a cation because it has more protons than electrons. And the anion is called anion because it has more electrons than protons. So when these atoms join together by a bond, distributing their electric charge, forming a compound, is called polarity. Now, structure of molecule. Structure of. Now, the next one, it says shapes of molecule. Shapes of molecule. The molecule has a linear shape, trigonal planar shape, tetrahedral shape, trigonal bipyramidal shape, octahedral shape, angular or bend shape, triangular pyramidal shape. Now, the first one is the linear shape. Okay? Is a molecule, the linear shape is a molecular shape in which the atoms are arranged in line. In line. Okay? They are arranged in lines. They are not arranged anyhow. Okay? They are arranged in a straight line. Not vertical, but horizontal. As you can see, the one you saw on your screen is carbon dioxide. While the carbon is in the middle, you get to know where you get to hydrocarbon. Okay? This is organic, this structure is organic chemistry under the Lewis structure. Okay? The carbon is the one that is always there because it's natural. So it's the one that is going to do the shearing to the artificial. So we get the carbon dioxide, we get the hydrogen molecule, we get hydrochloric acid, chlorine, nitrogen, etc. So all this, most of these linear shaped molecular structures are molecules that are diatomic. Most of them are diatomic. Most of them are diatomic. Take note. Now the next one is the trigonal planar shape. Okay? It's a molecular geometry model with one atom at the center and three atoms around the corner of the equilateral triangle. Okay, we say sulfur trioxide, SO3, boron trifluoride, and nitrates. If you check the structure on your screen, the nitrogen is in the middle. Now, the one that is monoatomic is always in the middle of the trigonal planar shape. Okay? This trigonal planar shape always talks about compounds. They are mostly compounds. Trigonal means three. In essence, the compound must have to have 4 molecules. 4 molecules. The first element should be 1, and the additional element should have 3 molecules. Now, the first molecule in the compound will be in the middle. If you check the sulfur trioxide, you see that the sulfur is singular, while the O3, the ozone, has 3 molecules. So it is a sulfur, when you want to make it a shape, it is a sulfur that will be placed in the middle in replacement of that N you see as nitrogen. Then you just put the 3 around, making a triangular shape. Take note. Now the next one is tetrahedral shape, 4. That's what it means. It's a shape of molecule that occurs when there are 4 bonds and no lone pair in the molecule's central atom. Tetrachloromethane, CCl4. Now, anywhere you see 4, now this tetrahedral shape, okay? Anywhere you see 4 molecules, okay, or 4 atoms in a compound, it means that shape of that molecule should be tetrahedral. You put the C in the middle, or you put the first element in the middle, and the element that has that 4 atoms will be around it, as you see on your screen. Remember, it's 4. The other one is 3. Okay? The 3 is triangle equilateral. Equilateral means the 3 sides will be equal. Why this is 4? Now, the 4, the 1 atom will have to react with 4 atoms to form the compound. Okay? Now, that molecule is a quadroatomic molecule. A quadroatomic molecule or a tetraatomic molecule. 4, depending on the name. If it's 8, it is octaatomic. If it's 10, decaatomic, depending on the name of atom. Depending on the number of atoms in the element, that depends on the name of the element. That depends on the name of the molecule. If it's 5, you know what to call it. If it's 6, you know what to call it. If it's 7, you know what to call it. So from the names, from the number of atoms in the molecule or in the element, we know the name of the molecule. Now they say this is tetrachloromethane, CCl subscript 4, ammonium ion, phosphate, methane. Okay? Now, the 2 elements that came together to form this compound, the second element must have to have this 4. In essence, the number of molecules in the compound should be 5. The first element is 1, and the additional element that is reacting should be 4. So the first element is used at the center, while the remaining element that has these 4 atoms will go round the structure. Now the other one is trigonal pyramidal shape. Okay, it's a molecular shape that results when there are 3 bonds and a lone pair of a central atom in the molecule. Ammonia, phosphine, hydronium ion. So if you check this particular shape, they say it's a molecular shape that results when there are 3 bonds alone. Okay, and a lone pair on the central atom in the molecule. If you check your structure, you see that the hydronium ion is being placed. Okay, hydronium ion is being placed. Now, in this case, the first one has the number of atoms, and the second one do not in the hydronium ion. So in essence, there's oxygen that is being sacrificed with its charge to get the shape correct. Now the next one is octahedral shape. Octa means 8. Okay. Now it's a molecular shape that describes the shape of a compound with 6 atoms or group atoms or lingers symmetrically arranged around a central atom. Symmetrically means when you arrange, okay, when you line your lines according to the cardinal points, the north, south, east, west, north, east, south, east, and so on. That particular arrangement is called symmetrically, a symmetric shape. If you check your screen, you can see it there and it's being angled. Okay. Now the central atom, remember is that the element that has the number of atoms, okay, makes the shape. The one that has the number of atoms makes the shape. The one that has no atom is always used at the center to complete the shape. Take note. The one that has the number of atoms makes the shape, as you can see. Okay, the fluorine is the one that makes the shape, while the sulfur completes the shape at the middle. It's being placed at the middle. Okay, and the electron pair. Okay, because it's the sulfur that has the number of atoms. So it's the sulfur that have the molecules. They are the one that are going to be the electron pair around the sulfur. Take note. The next one is angular or bent shape. Okay, it's a V-shaped molecular structure that is not linear in shape. As you can see, water. Okay, it's just a V shape. Okay, the one that has the one that does not have the number of atoms remains at the apex. At the point, that particular point at the head of the V. Then the one that has the number of atoms gives us the shape. When the slanting V comes down, it is those ones that are going to be there. But at the apex of the V, or at the point of the V, that point that the V shaped is being complete, that is where the one that does not have the atom will be placed. Remember, in these particular shapes, the element that do not have the atoms are the ones that are being placed, while the ones that have the atoms are the ones that are being used to make the shape. Take note. Now the other one is trigonal bipyramidal. It's a shape of molecule that has 5 bonds and no lone pair on the central atom in the molecule. Example, phosphorus pentafluoride, sulfur tetrafluoride, phosphorus pentachloride. As you can see the shape there, that is how it's been structured. It's still the same thing. Okay, it's still the same thing. The P there is used to be sacrificed. The S there, if you check the sulfur tetrafluoride, this is the S that is being placed in the middle, and the F being used to make the shape complete. Now, let's look at the molecular size and radius. Okay, the molecular size is 0.1 nanometers, the same as the atom. The same as the atom. And the smallest molecule is the diatomic hydrogen with a bond size of 0.74 Armstrong. The hydrogen is the smallest diatomic molecule. Hydrogen is diatomic, okay, because it has 2 atoms, so it's diatomic. It is the smallest diatomic molecule. And the molecular size and the molecular size of a molecule is the same as the atom, 0.1 nanometers. Both of them are the same characteristics like I told you. Now the radius, molecular radius, is the size of a molecule displayed in a solution. Every size of a molecule is the radius of that particular molecule. If I put a pinch of salt in a food, that pinch of salt, maybe the pinch of salt is 2 grams. That 2 grams becomes the radius of that molecule at that particular point in time in that solution. If I put 10 grams of salt in rice, that 10 grams of salt becomes the radius of that particular time. And I said, it is the size of a molecule displayed in a solution. Any size of a molecule you see in any solution becomes the radius of that molecule in that solution at that particular point in time. Okay? So take note. The next one is the difference between molecules and atoms. A molecule is the smallest particle of any substance, while an atom is the smallest particle of just an element. Every substance, the smallest is the molecule, smallest portion of any substance. An element, a compound, a mixture, any one. But the atom is only in an element. Molecules occur in free state, whereas atoms do not occur. Molecules move anyhow. Even in gases, they fly. They move anyhow. They are free like the bird. But the atoms are being caged. You know, they are being caged in an element. They are being caged in that element. They are caged in the element. Okay? They don't move freely. All they do is just to come together. That's all. They don't move freely. While the molecules have free movement, especially in gases. They move as they like. Molecules less reactive, but atoms are highly reactive. Molecules do not have ions. That's why they cannot be reactive. But the atoms have ions, so they can be reactive. They have electric charges, so they can be reactive. Molecules have covalent bonds, whereas atoms have nuclear bonds. Yes, the bonds that bind molecules together are covalent. When we get to the next class of compounds, you know that chemical combination. Why the one that has is nuclear bond? Why? Because the energy of an atom comes from the nucleus. And everything that comes to the nucleus is nuclear. So the thing that bonds these particular protons and nucleus together is the nuclear bond. Now, molecules do not take part in chemical reaction, but atoms do. Yes. Molecules, they take part in the reaction and change. The atoms change to molecules. The atoms change to molecules. Why? The molecule has smallest portion. They exist independently. They stay on their own. Okay? The reaction does not consume them, but the reaction consumes the atom. That is why they change to molecules. But for molecules, the reaction do not consume them, so they still remain independently as catalysts. Now, the similarity between atom and molecule, they say they are both smallest particles of substances. Yes, an element is a substance and compounds are substances. They say they are both electrically neutral in nature. Like I told you, the part of the atom that is neutral is called the molecule. And what makes the atom neutral is because they have the same number of protons and electrons. Now, if they form anything, that same thing will become neutral. Now, they are both pure substances. Yes. Okay? The molecules in a compound are pure substances, because we know that pure substances, the two types of pure substances we have are elements and a compound. And the atom is still a smaller particle of an element, which is a pure substance too. The combination of atoms forms a molecule. Yes, atoms and molecules are the same. Why? Because the atoms form the molecules. Your brothers and your sisters that your father gave birth to are the same, because the DNA runs in your vein. Now, they both have bonds. Yes, atoms have bonds, nuclear bonds, that binds the protons and the nucleus together. Molecules have bonds that binds two elements together to form a compound. Now, there's also a difference between molecules and ions. Molecules are formed by sharing electrons, whereas ions are formed by the exchange of electrons. When we talked about ions, you see how the charges are hitting, exchanging. Positive for negative, negative for positive, okay? While the molecules are they share electrons. They are formed by sharing electrons. Breakage of bonds. When these bonds are being broken, like hydrogen breaks, oxygen breaks, as they are breaking, their molecules are coming out. Their atoms are coming out, okay? When they come out, they join together and they will form molecules. Whereas in the ions, it's just the exchange of charges. When the positive hits the negative, it forms an electric charge. And we know that an ion is electrically charged. Now, molecules are chargeless. Molecules are chargeless, while ions have net charges. Ions have net charges, the positive and the negative. Molecules are neutral, so they are chargeless. Molecules have covalent bonds, while ions have electrovalent bonds. We talked about that the electrovalent simply means ionic. Okay, ionic, electrons coming together to form a bond, while the molecules are covalent. The covalent bonds are neutral in nature. Molecular size depends on the size of the atom, but the ionic size differs in its particles. Yes, the size of the atom determines the molecular size. Yes, if the size of the atom, because it is the atom that forms the molecules. So if the size of the atom that form the molecules are small, they will become small. It's like you want to cook soup, egusi soup. Now, the amount of cups of egusi will determine how the soup will be big. That's the same thing. The amount of atom coming together will determine how the molecular size will be. While the ionic size differs in particles. They are different in particles. Okay? The protons and the neutrons do not determine the ionic size. What it determines is the ionic charge. Now, similarities of both of them. They both contain bonds. Yes, they must come together as bond. They are both formed by display of electrons. They both have sizes, and they are both particles of matter. Both of them have sizes. They are both formed by the display of electrons. One is formed by the coming of electrons, and the other is formed by the sharing of electrons. So both of them have electrons in their name, electric charges in their name. They both contain bonds. Yes, one contains ionic bond that brings them together. The other contains molecular bond or covalent that brings them together. They are both particles of matter. So we've come to the end of this class today. But before we go, like we always do, let's use our exam guide in quantifying what we have learned today. Now we'll go to exam guide 2005, question 11. Question 11. They say, which of the following molecules has a linear structure? Linear structure. Linear structure, like I said, means straight. Okay? They are arranged, these molecules are arranged straight. They are arranged straight. The ammonia, no, does not have a linear structure. Water has a V-shaped structure. Okay? The methane has a tetrahedral structure, as we know. If you check, so the answer there is carbon dioxide. CO subscript 2. Remember, in the carbon dioxide, the C was in the middle and the O are the two edges of the structure. So the answer there is carbon dioxide. Now let's go to the next one, which is 2000. 2000 number 12. They say, what is the shape of a molecule of CCl subscript 4? Okay, what's the shape? Now, I told you that every single compound that has 4 atoms, that has 5 atoms, has a tetrahedra. Tetrahedra means 4. In essence, one compound, the first element must have to be singular, and the next element coming together must have to have that 4 atoms. Why? Because I told you that the first element, the element that do not have the number of atoms in it, that is monoatomic, will have to be in the middle, and the one that has the number of atoms makes up the structure. And if you check, the one that has the atoms that want to make up the structure has 4 atoms in the molecule. And that 4 atoms simply means tetrahedral or quadrahedral. Tetra is 4, quadra is 4. So the answer there is tetrahedral. Thank you for participating in today's class. You can practice more questions using the Exam Guide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the videos to people that will benefit from it. Bye.